shoot a bullet straight up, it'll come back down?
No, it was like if the gun's perfectly horizontal to the floor.
All right, moving on. So, speaking of a bullet, that's what our first problem's on. How about that? Now, with these problems, the first thing we need to do is, again, identify what does the problem give us, what does the problem want us to get, and things of that nature. Now, it's very important for us to understand some key concepts. We are now working in two frames of reference, in the X frame and the Y frame. So, horizontally and vertically. Some things go like in the same, in like both sets of equations, but there are other things that do not. So as we go through this, I'll try to define that clearly. Some of the notes from last night majorly tried to push that forward. And what were the two main things that we need to remember that are stay constant in a two-dimensional motion style problem? Jay, mask up, and then what are you trying to say? Okay, gravity is in which direction? Down. Or is that in the X or the Y? Okay, so we know that we have our AY is 9.8 and negative 9.8 meters per second squared. Next, what? So A is acceleration, and this is the acceleration in the Y direction. So AY, the acceleration in the Y direction. Okay? So up and down. Okay. Gentlemen, shh. Hey, I need you guys to, at this point, you can talk later. Now it's time to stop. All right. Next, what else is constant in these problems? Something in the X, yes. But what is it in the X? Is it the acceleration in the X? Is it a velocity? Is it a distance? It is velocity. Vx is constant. We are going to have no accelerations in the X direction. So what has occurred in all of these styles of problems is anything that was pushing the object, pulling the object, or anything like that, causing it to initially get to its original velocity that's given in the problem, is no longer acting on that object. It's like you throw a ball. You put a velocity into the ball by throwing it. But now the ball is no longer in your hand. You are no longer pushing it, giving it an acceleration. Okay? There's a big misconception in that you think, okay, the car is still driving, so it's going to be still accelerating. No. If the wheels aren't touching the ground and the car is flying off the cliff, doesn't matter if you're spinning the wheels. You're not going to be accelerating in the X direction. You're only going to be accelerating downward. Gabe. Correct. And most of the time, if we're dealing with that in our practicum, it's so small or negligible because we're dealing with spherical objects. Those usually have less air resistance that they will not affect our math. Okay? That doesn't surprise me, but I think it's more the fact that the lobster knows how to like compress itself, a Jeep Wrangler can't. All right, continuing along. On to the problem. Knowing that these things are constant, let's identify what's been given, what's not given in number one. A bullet is moving at a speed of 367 meters per second. when it leaves the barrel of a gun, which is 2 meters from the ground. Okay, what do I know so far? What type of velocity do I have so far? I have an x velocity, which is 367 meters per second. Again, is this velocity going to change? No, it's not. Okay. Next, I also know that that is a horizontal velocity because, by the way, it says it's like leaving a gun and it's not saying the gun is being fired straight up. So you can assume that it's being shot horizontally because that's how most people shoot a gun. Okay. What does this 2 tell me? Okay. I hear height, I hear y. So let's be more specific. Let's call this dy. So the distance in the y direction, which is 2.00 meters. All right. What else should I be able to assume about this scenario? I should be able to assume AY is negative 9.8 meters per second squared. And there's one more thing I should be able to assume. We've talked about this style of problem before with Marvin the Menace. Okay, in the x direction, we know the velocity isn't going to change. In the y direction, we know it is going to change. If I was going up, yes. So, but it is 0 when I start. So the initial y velocity is 0 meters per second. John, put your computer away. Okay. Now, here's the thing. The problem asks us to figure out how far the bullet is going to travel before it hits the ground. We know it's going to travel 2 meters down. So what we're asked to solve for is dx. So to solve for dx, I am going to be using the following equation. Velocity times by time gets me d. Now, I've got to be thinking in the x direction for this to occur. I've got to be using the velocity in the x direction and the distance in the x direction. From this equation, what variable or what variables do I not have in this equation? I've got Vx, it's 367. I don't have dx. What else do I not have? Time. Time, it's in the air. Now, I could solve for the time it's in the air because the time it's in the air is dependent on one key thing. What is going to determine how long the object is in the air? Okay. It's not just gravity. Okay. It's not dealing with the gun. When the y value hits 0. Yes. So what are you saying? Okay. But Jay, what are you talking about before you get to that point? Okay. Jay's talking around in circles. Brody, you can help him? Correct. The time would be if 0 at the start. Yes, until it hits the ground, then it'll be a different time. No, you didn't quite help, Brody. Sorry, almost. Okay. Here's what determines the time. Listen carefully. Shush, please. The time is dependent on the height the object is off the ground. It does not depend on the x velocity. Some people get confused by that. It does not depend on the x velocity. It determines based off the height it is off the ground. Okay? So, time, I'm going to put this up here. Time is usually dependent on dy. There's an exception. If I have the dx and the vx, I can get time. But I don't in this scenario. So, here we go. Before I can solve any problem from here on out, this is the first step you need to do. Everybody got this? First step you need to do on all kinematic problems from here on out. First step, solve for time. That's going to be the first step from pretty much here on out. Is the first thing you need to do is solve for time. Okay? So, again, I'm going to state that here. Solve for time is like the first step. It's very important. That's what we need to do for all of these problems. So the question is, how do I solve for time? Okay, so I'm going to be paying attention to, again, the dy information because that's what determines my time. So I'm going to be, in essence, saying, okay, I don't know my time, but I have dy, ay, and initial velocity being 0. If I know those these three things and I'm looking for time, which kinematic equation, ones that we had in the unit before vectors, should I use? Okay, so get out that equation card. Figure out which equation has these 4 variables in it. Vx here is just the velocity. Vi is the initial velocity, or VIY. Okay, so the equation I should use to solve for time I need a 1/2 at squared. Okay, so again, d equals VIT plus 1/2 at squared. But this is all in relation to y. So I should be like dy, VIY, AY. Okay, this is all in the y orientation or up and down orientation. So then I will plug in my values. I've got 2 equals 0 times time, which is going to be 0 eventually, plus 1/2 negative 9.8 times it by time squared. Now, I'm also going to mention one other thing, because if you started doing this and plugging this in your calculator, you'll get what your calculator says is an imaginary number, and it won't allow you to do it. So there's another simple assumption that we need to do, This object is falling. So the direction that the object is going is down, right? And the acceleration is going down, right? So we can assume both of them are in the same direction, thus both of them are negative. Or both of them are positive. You choose, okay? But the negative in this scenario does not have an effect. It's just telling us the direction it's going. So in the end, to get time by itself, we are going to be doing the square root of 2 divided by 1/2 of 9.8, which is 4.9. So I did half of 9.8, which is 4.9. And this got canceled out because it's 0. And then I divided 2 by that and square rooted it. Okay? So I will write it out a little bit more. Algebra. So the 0 times t plus 1/2 9.8 t squared. So I've got 2 times 4.9 t squared. Right? Because 0 times t is 0. Then divide both sides by 4.9. 4.9 t squared equals 2 divided by 4.9. Square root both sides. T is going to be equal to square root of 2 divided by 4.9. Now, I'll actually put that in my calculator and get an answer. Okay? Just FYI. But that's the full algebra on that problem. Okay? So once you plug it in your calculator, you get a time of 0.639 seconds. So again, our first step is to solve for time. We solve for time, and we'll always solve for time using, in Cliff problems, this equation here pretty much. Almost every single time we have a standard Cliff problem, we are going to use this equation to solve for time. Okay? And we're going to have a very similar setup to solve for time. So now that I have my time, 0.639 seconds, I'm now able to use this equation here. So now I'm going to start plugging things in. dx is going to equal 367 times it by 0.639 seconds. And my dx is be whatever 367 times 0.639 is, which is 234.5, which makes this 235 meters. Okay. All right. I want you to try to solve 2. 2 is a slightly different problem. It's got slightly different numbers, but the process is the same. Go ahead, try to solve 2 on your own.